Hey guys, we're going to continue our conversation, excuse me, about ratio tables, but we're going to talk about the situation when you can't get from a given number to a number they want you to get to. Like it doesn't go directly. They're like trying to get 18 to become 5. Okay, so what we're going to do is something called scaling. So that's what we're going to talk about. This is still lesson 1.4, and we're going to call this scaling tables. So basically, it's going to take more than one step to get from some given information to a target number, okay? So let's get a definition for scaling. So scaling is going to involve one of two operations. So in scaling, you're going to, multiply or divide two related quantities. And quantities is just a fancy way of somehow these are related, so we're just going to call this basically they form a ratio. So multiply or divide two related quantities, they form a ratio, by the same number. Now you might have noticed in the ratio tables that you guys took the notes on, and as we practice in class, you're going to see that they usually have like 3 columns, but sometimes you can get from the first column to the gold column in one step. You don't need to take bite-sized steps to get there, okay? So this one's going to be dealing with, we can't get directly, so we are going to use that middle column. So depending on what you're doing, we're going to have a couple of words. So we can take scaling and we can say scale up or forward. Well, that was a terrible W. And that means we're going to multiply the values in a ratio So multiply the values in a ratio to reach a target number. Now I'm going to put a word in here, a phrase that we're going to be take notes on about a little bit later. But basically what we're doing is we're going to create what's known as equivalent ratios. So those are two ratios with equal value. Okay, so that's really all we're doing when we scale up, or in the other case, scale back. We're just trying to create an equivalent ratio. So we'll talk more about that. Scale back. So to scale back, we're going to use a different operation. We're going to divide. So you're going to divide the values in a ratio to reach a target number. And then again, that's to basically create equivalent ratios. Okay? So in other words, you get to play math detective. So you get to play a math detective. So you're trying to figure out how to get from one number to a next, okay? So I'm going to give you a couple of examples, and then we'll give you some real-world ones. So let's say we've got height that's in centimeters, and we're going to compare it with height that is in inches. And let's say, let me create a nice table here, all enclosed. And we're given that 25 centimeters would be the same as 10 inches. And the question is, how do we get from 25 to 105? And the answer is, there's nothing you can multiply 25 by in order to get to 105. So what you're going to do instead is you're going to look between these two guys. Is there something that you can do to 25 and 10? So what we're going to do is, I noticed that they're both divisible by 5. So we're going to scale back or divide both of those by 5. Let's see what we end up with. So we end up with 25 divided by 5 is 5, and 10 divided by 5 is 2. So now, can 5 go into 105? And the answer is sure, ends in a 5. So I'm going to go bigger, so I'm multiplying, so I'm going to scale up now. And I have 5 goes into 10 twice, and 5 goes into itself once. So if I multiply by 21, if I multiply 5 by 21, I get to 105. So that means if I multiply or scale up 2 by 21, I get 42. So what we said is we scaled back by 5. That means we divided by 5. Our beginning ratio in order to get to a value that we could then scale up. So we scaled up by 21. So we multiplied by 21 so that we could get to the goal number of 105. So basically what we can conclude from this, someone who is, wrong number, 105 centimeters tall is 42 inches tall. So that's what we were discovering here. Is what height would somebody who's 105 centimeters in, let's say, Britain be if they came to the United States? All right, let's try another one. Speaking of foreign, let's compare the American dollar to the Canadian dollar. So they have dollars as well, but their dollar is not the same as our dollar. It's not worth the same. So we have to do a conversion if we wanted to go from one to the other. So we're told if I have 50 American dollars, that's the same as saying 60 Canadian dollars. So the question becomes, how many Canadian dollars would 20 American dollars be worth? So let's see, I can't go from 50 to 20, and I definitely need to go smaller. So let me think. What could I scale back by? I could scale up. We could do that too. That's always something that's a possibility where you can scale up, but then you're going to be creating bigger numbers, and then you're going to have to take those bigger numbers and make them smaller. So I tend to try to scale back if I possibly can. And straight away I noticed that both of them end in a 0, which means I could scale back by 10. And that would give me a 5, and I know 5 goes into 20, so that's what I'm going to do. is I'm going to scale back or divide by 10 each of the numbers. And that's going to give me a 5 and a 6. And then 5, I would need to scale up by 4. So I'm going to multiply 5 by 4 to give me 20. So I multiply the other part of the ratio by 4, and I get 24. So again, let's write down what we did. We scaled back by 10. So we divided by 10. And then we scaled up by 4, and that meant we multiplied by 4. Okay, so I could multiply by 4 or multiply by 2 and scale back by 10 or by 5. So there's lots of different ways to solve this. It's not just one way to do the math, okay? So I always try to reduce first, and then that's just my thing because I'm so used to taking fractions and reducing them. So let's see, $20 American is the same as $24 Canadian. Okay, so again, it's just trying to help me figure out a particular equivalent ratio, a ratio that has the same value. All right, I've got a couple other examples. Let's do those. So I'm going to set this up off camera and then come back, and then you can pause and copy it down as well. So our scenario is we have cans of corn are on sale at 10 cans for $4. So find the cost of 15 cans. So the best thing to do, and often your book will provide this information for you, is you take and you use words first. So cans of corn. So just like in the ones we did with the ratio table, we took the situation and we wrote down the two things that were being compared. Okay, so we're going to compare cans of corn, and then that's going to be compared to cost in dollars. Okay, and then I'm going to do 3, but we don't always end up needing to use the middle one. Sometimes we do, so I just put it there. The book puts it there just in case you need to. So let's say, so now the good thing about writing those words, it's going to help me place the numbers in the right spots. So cans of corn are on sale at 10 for $4. So 10 is cans. So you put the 10 with the cans of corn, and the $4 would be with the money. And then it says find the cost of 15 cans. So I got to make sure that I put 15 in the can row. So it's going to go up here. And yeah, I cannot get 10 to become 15. Okay, so here's what I'm going to do. I'm going to scale back because I noticed that 10 and 4 are even. So I'm going to divide by 2 for each one of them. That's going to give me 10 divided by 2 is 5, and 4 divided by 2 is 2. Now I can scale up, because I know if I multiply 15 or 5 by 3, I'll get 15. So if I multiply 2 by 3, I'm going to get 6. Okay? So let's kind of off to the side. What did we end up doing here? We scaled back by 2, so that meant we divided by 2. And then we scaled up by 3, so that meant we multiplied by 3. Okay, so let's draw my conclusions. And I could say it will cost, we're going to just look at that last column, $6 for 15 cans of corn. You got to really like corn to buy 15 cans of it. I like to just buy what I need, maybe have one extra, but You buy too many of them, and, they will go bad eventually, right? Okay, I'm going to do the same thing. I'm going to pause. I'm going to copy down, and if you feel free to pause once I come back on again, and then copy it down, and then go from there. Okay, sometimes when we do real-world situations, it's a lot of writing. So we've got Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? Now, one thing I did want to bring up that we have been doing is we keep calling these ratio tables, but the reality is they could be rate tables. Ratio and rate tables are interchangeable. The difference is ratios are two numbers with the same label. Rates are two numbers with different labels. So far we've been looking at rate tables with different things we were comparing. All right, so go ahead and take a moment, copy that all down. When you're done, come on back. Okay. All right, so let's get working. So let's see. They tell us how long he takes to mow and how many lawns he mows. So that's going to be my two things. So we've got number of hours. And again, most of the time your book provides the labels for your table. If it doesn't, you just pick it from the information that's given. Number of hours versus, oops, that's weird, number of lawns. Okay, and then we look, he took 14 hours, so that's given, and to mow 8 lawns. Okay, and then it says, how many lawns could he mow in 49 hours? So 49, it goes with hours. So that's the trick here, is where are you going to be placing the third number? You got to look at the labels, just like we did with dimensional analysis. It's really important to pay attention to the labels. So let's see, 14, I can't multiply 14 by anything to get to 49, but they do have a 7 in common. So could I get to 7? You know what I'm going to do? I am going to scale back by 2, since both numbers are divisible by 2. So this is the key. When you either scale up or scale back in particular, it has to be a number that goes in evenly into your two original numbers. So when I divide 14 by 2, I get to 7, and when I divide 8 by 2, I get to 4. That gives me the ability to now scale up to 49. 7 times 7 is 49, so I multiply 4 by 7, and I get 28. So just to recap, we scaled back by 2, so we divided by 2, and then we scaled up by 7, and that meant we multiplied by 7, okay? So what is our conclusion? Let's see. Joe can mow 28 lawns. So I just am taking the question, how many lawns can he mow? And I'm writing it as a statement. Joe can mow 28 lawns in 49 hours. And again, like I said, there's more than one way to solve these problems. A lot of times you can scale up first and then scale back, but sometimes it's hard to figure out the right number, okay, to scale up by. All right, good luck with this, guys. We'll see you later. Bye now.